Hello class, I just want to make some more videos. I just gave up on the other videos trying to get those loaded. I just was unable to. They must have been corrupt or something. Plus I had to go to Chicago for business. So I'm back in town. I'll make some more videos, try to help you with the quiz number 3 and the midterm examination. I'll try to explain some of that. First I want to go over what the normal distribution is. The shape and position of the normal distribution curve depend on 2 parameters, and that's going to be the standard deviation and the mean, the population mean. So that's why I had you do those exercises pretty early on, because understanding where the mean and the standard deviation come from are pretty darn important when we get to this part of the textbook. And understanding the mean and standard deviation is going to be critical as we move forward into hypothesis testing, which I'll make videos on that later this week as well. So each normally distributed variable has its own normal distribution curve, which depends on the value of the variable's mean and standard deviation. Again, the standard deviation and the mean come into play. Very important statistics that we're going to be talking about. So basically, understanding the shape of a normal distribution is pretty critical as well. It is symmetrical in shape. It has negative values and positive values, and the mean, the mode, and the median on a normal distribution are going to split that distribution into 2 equal halves. So I should have some pictures. Here we go. And on a z distribution, which is going to be a normal distribution, it's called the z distribution. So we're going to have standardized scores, which are z scores or z scores. The mu, or the population mean for a standard normal distribution, is always going to be 0. 0 is going to be the mean. Now we're going to have values of 1, which are going to be our standard deviation. So we're going to have positive values to the right of the distribution, and we're going to have negative values to the left of the distribution. So we're going to break up this distribution, and it's the same thing as a frequency distribution. We're going to have scores along the x value, or the x-axis, I'm sorry, and we're going to have frequencies on the y-axis. And as you can see how the curve dips down, and it never does touch the x-axis. It goes on for infinity. It goes on forever and ever. So you could have values of positive, 10 standard deviations. There's no limits to how far that goes. Excuse me. So again, with this shape, it's bell-shaped. It is symmetrical about the mean. That means that if I fold this in half, the right side is a mirror image of the left side. The shape of the distribution as it goes higher and as it goes lower, and we'll see that in distributions called t-distributions, they change in shape depending on degrees of freedom, basically how many groups you have or how many are in each group is going to depend, the shape is going to change depending on that. So we call that kurtosis. So as the shape gets long and skinny, we call that leptokurtosis, and as it gets short and fat, we call that platokurtosis. So I don't think I'm going to have any questions on kurtosis. There's a big long formula for that, so I'm not going to worry about that in this class. If you decide to take further statistics classes, you'll run into kurtosis. Here's some properties of the normal distribution. The normal distribution curve is bell-shaped, like I said. The mean, the median, the mode are all equal. They're right in the center of the distribution. The normal distribution curve is, it has one mode. So it's not bimodal, it's not trimodal, it has one mode, unimodal. The curve is symmetrical about the mean, which means the left is a mirror image of the right and the right is a mirror image of the left. And the mean, the mode, and the median pass right through the center of the distribution. The curve is continuous. It goes on forever. Like I said, there are no gaps or holes. For each value of x, there is a corresponding value of y. The curve never touches the x-axis. It goes on for infinity. Theoretically, there's no end to it. So, like I say, there's no limits to how many deviations that you can go. The total area under the normal curve is equal to 1 or 100%. And what we talk about in this class is percentages under a certain area of that curve. And on the quiz, there's a lot of questions about that, and I'll try to clear that up as best I can. One standard deviation of the mean is approximately 68%, and what that means is plus and minus 1 standard deviation from the mean. So if I go 1 standard deviation plus, and I go 1 standard deviation